A very good afternoon to my supervisor Dr. Aksha and my internal examiner Dr. Kaur. I am Sri Ganesh from Group 2. Today I will be presenting on the detailed equipment design for methanol synthesis reactor R302. In my presentation, I will be presenting on the introduction, design methodology, reactor type selection, sample calculation, specification sheet, technical drawing, and finally reactor cost estimation. As for the introduction, the main purpose of methanol reactor R302 is to convert syngas from DMR to methanol via catalytic hydrogenation of CO2 with H2. The reaction involved in this process is 1 mole of carbon monoxide together with 2 moles of hydrogen to produce 1 mole of methanol. The overall carbon monoxide conversion in this process is 94.7%, and the recommended catalyst to be used in this process is a copper-based catalyst consists of copper oxide, zinc oxide, aluminum oxide, and chromium oxide. The operating temperature and pressure for this process is 210 degrees Celsius and 76 bar. The overall methanol synthesis process unit is shown in figure above. The design methodology for methanol reactor includes reactor type selection, selecting suitable operating condition, calculation of volume of reactor, determine size of reactor, mechanical design of reactor, cost of equipment analysis, technical drawing, and finally description of startup and shutdown procedure. There are two types of reactor technologies available for methanol synthesis, which are multi-tubular reactor and multi-stage fixed bed reactor. Both of these reactors requires reactant to be exist in liquid or gas phase. As for the catalyst, it must exist in solid phase. The working principle of multi-tubular reactor is based on a tube and shell design, whereas multi-stage fixed bed reactor uses a series of heat exchanger to cool down the outlet stream. The advantage of using a multi-tubular reactor is it can produce steam, requires lower catalyst volume, efficient temperature control to maximize reaction rate. As for the multi-stage fixed bed reactor, the advantages are it requires a lower reaction temperature, increases in conversion per passes, and has a higher driving force. The limitation of this multi-tubular reactor is it has a complicated design and it is expensive. However, a multi-stage fixed bed reactor has a limitation in terms of it can only be used in a small scale production and requires a larger volume. In this project, a multi-tubular reactor is chosen as a methanol reactor design because the advantages of this reactor outweighs its limitation. As for the sample calculation, reactor volume, catalyst volume, reactor weight, reactor dimension, nozzle and piping sizing is taken as a sample calculation in this presentation. The calculated reactor volume in this project is approximately 2300 meter cube. As for the catalyst volume is 600 meter cube. The reactor dimension in this project is it has a height of 30.85 meter and a diameter of 11.64 meter. As we can see on the specification sheet of reactor R302, it includes its operating data, mechanical design, and the type of catalyst used in this process. Moving on to the technical drawing, an AutoCAD software is used to draw the reactor design. In this technical drawing, it includes detailed reactor dimension, catalyst bed dimension, and torus head dimension. Lastly, as for the reactor cost, the purchase cost of this reactor is approximately 1.2 million USD and the install cost is 3.8 million USD. Finally, the catalyst cost in this project is approximately 800,000 USD. I will end my presentation here. Thank you.